Hello everyone, welcome to this video. In this video, we'll be solving this question which states that U15 has 6 cyclic subgroups. This is given to us. We have to list all the given subgroups, correct? So we already know what is this group U15. U15 contains all the elements which are less than 15 and are relatively prime to 15. So this forms a group under the operation of multiplication modulo 15, right? So we multiply two elements and then we take its mod 15 and the remainder is your answer. So here let's see what is the group which is generated by 1, 2, 4, 7, 8, 11, 13 and 14, each element of this group. So the group which is generated by 1 is obtained when you take the powers of 1. So basically 1 raised to power 1, 1 raised to power 2, 1 raised to power 3 up to 1 raised to power 8. Right, and when you solve each one of them, you only are going to get the element 1, right? So therefore in this case you only have one element present within your set, which is 1, hence it forms a trivial subgroup. And in fact, why it is cyclic? Because it is generated from one single element, correct? So we obtain one cyclic subgroup, correct? We have to obtain 6 of them. Let's see 2, the subgroup which is generated by 2. The subgroup which is generated by 2 is obtained by taking different powers of 2. So when you take different powers of 2, starting from 2 raised to power 1, 2 raised to power 2 and going up to 2 raised to power 8, you will see you only have 4 different elements which are 2, 4, 8 and 1. Correct? So when you take 2 power 1, it is 2. When you take 2 power 2, take its mod 15, it is 4. 2 power 3 is 8. 8 mod 15 is what? It is again 8. Then 2 power 4 is 16. 16 mod 15, it is equal to 1. Right? Why? Because when you divide 16 with 15, you have 1 as the remainder. Correct? So therefore you have 1. Then you when you take 2 raised to power 5, it is 32. 32 mod 15, it is equal to 2, which is again the same number. So the numbers start repeating, so you do not have to calculate for these because it would just be 4, 8 and 1. You can check this thing, right? So this is our second cyclic subgroup which we require, which is generated from 2. Let's look at another one which is generated from 4. The one which is generated from 4 is obtained when you take powers of 4. 4 raised to power 1, which is 4. 4 raised to power 2 is 16. 16 mod 15 is how much? It is 1. 4 raised to power 3 is 64. 64 mod 15. We have to calculate this. So it is again 4, right? 4 raised to power 4. How much is that? It is 256. 256 mod 15, right? You have to calculate this thing. Now when you calculate this, you will be seeing that we get the answer as 1. So you see the numbers start repeating 4 1 4 1 and so on. Next would be 4 1, next would be 4 1. So you only have 2 elements within your set, which is 4 and 1. Hence you obtain this third cyclic subgroup of this group U15, which is generated from 4. Correct. Next let's have a look at the subgroup which is generated by 7. It could be written like this: 7 raised to power 1, 7 raised to power 2, 7 raised to power 3 and so on up to 7 raised to power 8. So 7 raised to power 1 is just 7. 7 raised to power 2 is 49. When you calculate 49 mod 15, how much is that? It is equal to 4. So you obtain 4 here. Right. Similarly, when you calculate 7 raised to power 3, 7 raised to power 4, 7 raised to power 5 would again be 7, right? And the numbers would keep on repeating. So no need to calculate all of them. You just have to solve for all of these. So you get the answer as 7, 4, 13 and 1. So this is the fourth cyclic subgroup which you obtain, which is generated from 7, correct, out of the 6 cyclic subgroups. Next, let's have a look at the subgroup which is generated by 8. So the subgroup which is generated by 8 is what? It is the same as that generated by 2. Why? Because you can write 8 as 2 cube. So the subgroup which is generated by 8 is basically the subgroup which is generated by 2 raised to power 3. So obviously it would be equal to the subgroup which is generated by 2, correct? So You can also verify this thing if you take 8 raised to power 1, 8 raised to power 2, 8 raised to power 3 and so on. Here for larger calculations you might require calculator, right? Otherwise when you calculate mod 15 of it, you will be looking at the numbers. The numbers are 8, 4, 2 and 1, correct? So they are exactly the same numbers, hence they and they both are the same, hence we cannot say this is our next subgroup. Why? Because we have already taken this as our second subgroup, which is generated by 2. Next, let's have a look at the subgroup which is generated by 11. It contains only 2 elements, 1 and 11. The procedure is same, correct? And then for 13, it is equivalent to that of 7 because these members and these members are exactly the same, correct? And for 14 you have 14 and 1. So basically you reject this one, correct, because we get a repetition here. So this becomes our 5th cyclic subgroup and this becomes your 6th cyclic subgroup. Hence we, from the elements here, we obtain 6 cyclic subgroups of U5, which are listed as the subgroup generated by 1, that generated by 2, 4, generated by 4, generated by 7, generated by 11 and generated by 14. And this is our answer. So I hope you understood this question well. Well, that is it for this video. Thank you for watching.